So we talked about infinite functions, and usually when they're infinite, we have to describe them in terms of equations. So sometimes there can be patterns, but usually this is an infinite set. So we had an example earlier. We said something like y equals x plus 2. You can graph that. That's a linear function. Looks something like this, slope of 1, y-intercept of 2. Anyway, we can express then our function in terms of x and y, real numbers, okay? So when we do that, we talk about what's called the independent variable. The independent variable, like in this case, would be x. So we're saying we're going to put an x in, and then we're going to figure out what y is, okay? So we're going to take a real number. So pick a real number. And add to get y. And so y is the dependent variable, okay? So our y is in terms of x, okay? So that's another way to say it. Y is in terms of x. Oops. Okay, so the dependent variable in this case would be y. All right. So how are we describing the output? It's like input and output, like input and output. I take a real number, I put it in, I add 2, and I get out another number, okay? And then we have to know, is it a function? Now I told you this one was a function, because for every input, so think of a real number, you're only going to get one output. For my example here. Not everything's a function, but in this example, it's a function. So you give me any real number. When I add 2 to it, there's only one thing I'm going to get out. Okay? All right. So it's a little confusing, but the examples will help a little bit. So how do you determine if something, let me back up. How do you determine if something is a function? Get y by itself. So solve for y. Solve for y. And then you'll know. If you only get one output, then you'll know it's a function. If you get 2 outputs, well, then it's not a function. Okay. So here we go. We'll see an example. So I'm going to take my a here, and I'm going to get y by itself. So I'll subtract the x squared. So I could write this function as y equals negative x squared plus 4. So I could make a table of values and I could graph this, right? Okay, so I could put in, different numbers. But all of those numbers, I'm only going to get one output, okay? Now the output might be the same, like when I put in negative 2. If I put in negative 2, I'm going to get 0, by the way. And if I put in 2, I'm also going to get 0. You can play around with that. But I can have a duplication on the output, but I can't put in like a number, like put in negative 1 and get 2 different things out. But I'm not going to. So this is a function. A function. Yes, it's a function. Yes. Okay. Now you might be saying, well, everything's going to be a function then. No, not everything's a function. So if I go to this equation here and I want to get y by itself, okay, I can subtract the x squared. We did that a minute ago. Looks like that. But I have y squared. I don't have y. Well, how do I solve? I have to take the square root of both sides. Oh, but I'm taking the square root, so don't forget the plus or minus. And so this could be written y equals plus or minus the square root of negative x squared plus 4. Okay, now this is not a function. And you want to know why? Because if I make a table of values, x and y, let's say I put in the number 1. I am going to get 2 different outputs, one with a positive case and one with a negative case. If I put in 1, I'm going to get the square root of 3. And I'm going to get negative square root 3. So I get 2 different outputs. So it's because of the plus or minus. So not a function. Okay, that actually graphs to be a circle. It's still a relation. So not a set of ordered pairs is a relation. Some relations are functions, but all functions are also relations. So, but not every relation is a function.